Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about a very exciting topic of Risc-V first single board computer. So let's dive right into it. Now you have to understand who is the manufacturer of this puppy. It's made by StarFive. Now StarFive is a company that's sole purpose is promotion of Risc-V, because Risc-V as a instruction set architecture is open, meaning nobody technically owns it. It's almost like Linux. You can take the kernel, you can modify it and you deploy in your product. You don't have to pay licensing fee. However, if you're making something like that, it's almost like a language. Languages are only alive if people are using it. If people don't use it, it's kind of pointless. So Risc-V needs something to deploy it into the market, so to say. So StarFive is the company that's taking care of that job. Now they had made development boards in the past, meaning you're gonna make this board and you're gonna give it to the customers, and customers gonna experiment with it, and they're like, you know what, I can use this instruction set architecture, I can use this core design, I can deploy it into my products and all that jazz. While they worked, but they had a problem of cost, meaning these puppies were $800 plus. So it's something that, again, big companies like Western Digital and things of that nature, they can afford it without any issue. But again, that's very good for hardware level development, but really bad for software level development, because software people generally don't have that kind of bank balance. So they are directly now targeting a development board which is less than $200. Now again, I'm talking about single board computer, and the first single board successful computer is Raspberry Pi. And Raspberry Pi is like started at very low cost, as in like $25, $35. It's like, why the heck we are randomly talking about like $200? That's expensive. Now be mindful, that's the maximum price that I'm telling you. You can get it as low as $150 or sometimes as low as $135, depending on which country you are, VAT, extra tax and all that jazz, shipping and all that jazz. So generally they are targeting under $200. Now single board computers are right now is the hot item, meaning they are very good software development, meaning you're gonna sell this to people who are building hardwares. But how the heck you make sure, like, you have the instruction set architecture, you have the kernel, how the heck you make sure you on OS is good? Because again, hardware people, they generally reach to kernel level, they write their own stuff. Again, the people who are using this tool, they are only working command line. That's good and awesome for server kind of people, but not really good for common folks. So if you want to make sure Risc-V is a good name, as in like how ARM is a good name, how Qualcomm is a good name, you want to make sure this reaches common people, and common people will not touch it if you are like, yeah, use command line. They're like, nope. So to make sure that nope does not happen, they are making single board computers, and this will spur a development in the software department, meaning the operating system will be more refined, it will have more packages, it can run more applications. And once people see that, like, yo, I can run an operating system on it, I can play games on it, I can do Photoshop on it, I can run GIMP on it, things of that nature, that will turbocharge the growth of the Risc-V architecture. That's why this is created. Now it is expensive, let's not joke around that, but again, it had to be done because it does not have the same manufacturing capacity as ARM processors that are used in Raspberry Pi. And not to mention, Raspberry Pi is kind of successful, they came very early on, their community started to grow exponentially, so they can place much larger order. So again, there are some vectors that are making this bit more expensive than it has to be. So what's the core behind it? The core is VisionFive version 1. This is the board name, and the system on chip is JH7100. Now that name does not make any sense, but be mindful, over time, over years, it will start to make sense. Same way when I say Intel i5, Intel i7, Intel i9, you kind of get some feeling, some vibe to it. Why the heck that happened? Again, decades of market experience, same thing will happen here. Again, right now JH710 does not mean too much, but over time it may start to mean something. It has dual core processor, 1.5 gigahertz, and the core is U74. Now U74 does not make any sense to you, but U simply means is the maximum gradient core. They have 3 variants. They are trying to replace every single computation market, meaning from as small as Arduinos, like basically microcontrollers that are used in your stabilizers, refrigerators, things of that nature, to bit more middle range, like in basically Internet of Things kind of equipments, lightweight kind of processing, and then high weight, like computer kind of processing, that is U core. That's the highest end one. So this puppy is a 64-bit fully featured CPU, meaning it's not cost cut down, it's not designed for like lowest power consumption, it's a full-fledged system. Now what is the equivalent of it? Equivalent is ARM core A55. So if you are familiar with any mobile phones that have A55 kind of processing, expect similar horsepower but less efficiency, simply because again, ARM has been in the market for so long that all of the operating system, all of the software ecosystem has been refined for it. So it's not just the hardware, it's just software. They have to make love to each other. ARM has reached that threshold. Risc-V is new, so even if they had more horsepower, it may not translate to a good experience. And anybody familiar with the early days of Android knows this for a fact. Now it also has a 10 Celica VP6 vision processing unit, meaning they are charging more, but they are also giving you a bit more oomph to this, meaning this puppy can do a proper vision analysis of dual stereo camera if done correctly, and then you can crunch that signal using NVIDIA deep learning accelerators, NVDLA. Now NVIDIA is a generally very hated company in Linux community simply because they flat out block their graphics driver. While that is an issue, this time NVIDIA, because they are a member of Risc-V association, they have created a new basically product SKU. This product SKU is like deep learning accelerators, how their Jetson Nano is created, similar thing. This meaning once you have a neural network that has been trained, you can run that on something low power as single board computer. So this is targeted at artificial intelligence in Internet of Things kind of equipment. Meaning, think of it this way: let's say you have a security camera. Security camera is like, you know, capturing the footage and all that, just everything is awesome. But what if it's also doing object analysis and storing that into a database? Let's say your footage gets corrupted or hard disk or something like that, but your database is still there. You can see who was there, when was there. It could be helpful. Again, that's just one case example, but you get this idea. Like, a lot of things may benefit from having artificial intelligence in them. So having a deep learning accelerator there, it makes that operation far more efficient. Again, you may try to run basically Android in it. You can do that. People have put like complete Android 10 on this puppy. But again, these are development boards, very expensive. So what's the spec of this puppy? This is around two chips of 4 gigabyte, basically 2.8 gigahertz RAM modules, basically low power DDR4 variants, and it's really good, like a good amount of RAM, like 8 gigabyte is good for single board computer. 2.4 gigahertz Wi-Fi, which is okay, and Bluetooth 4.2, good, and it has same 40-pin IO system, GPIO system. Now be mindful, GPIO at this point in time, 40-pin GPIO has become industry standard because of Raspberry Pi. So every company that tried to clone basically Raspberry Pi, they still create the same 40-pin general purpose input-output pins. Now these pins basically, what does that mean for you? Meaning, if you have Raspberry Pi and you are using those pins, you can just plonk it out and put it here. From a voltage point of view, from a technical point of view, it will work. It's just you have to redo the software on this hardware side, nothing else. Basically it's intercompatible, so that's kind of awesome. It has full size HDMI, which I really love. I hated the fact that Raspberry Pi literally went into like 4K output. I'm like, dude, you can't crunch video that fast enough. There is no point of having dual display. But apparently some people are saying that some call center people asked for that kind of thing. That's why our Raspberry Pi association did that. But again, tiny pins, ports, they're really hateful, and it's expensive also. So they're using full size. That's awesome. And they also have USB-C for power delivery. It does require up to 3 amps power adapter. So do not use the cheapest adapter you can find. You may need something a bit more beefy. And it has 4 USB 3.0 ports, meaning you can connect some awesome things to it. Even if you want to, like, you can connect Intel's AI accelerators that are like USB sticks. You can plug them there. You can make even a lower end basically network attached storage. You can do a lot of things. Again, these are gigabytes spec, so it's kind of good for this kind of prices. Now, what was the software? Hardware is meaningless if it does not have the software around it. And basically, founder of Linux created a very interesting data point. It's like, when you talk about instruction set architecture, it does not matter. What matters is like what's around it. Meaning, if you have x86, what is present around it? What can you do with it? The answer is everything. What is there in ARM? Lot of things. Not exactly 100% of x86, but a lot of things, and more things are being ported to it. But when you are talking about Risc-V, Risc-V has to do the same thing. There is no point of having like, this is open source, this is amazing, efficient, safe, secure. Nobody's gonna care if they can't do things on it. They will like, yeah, let's say Adobe has to port their application to run on it, and if they don't, let's say you make a laptop with this puppy, it's not gonna sell. That's the whole point. It has to have things that run around it. Software is that things. Now Linux Fedora Remix is default OS, meaning they're gonna provide this puppy to your this package in your micro SD card, and it's a bare minimum OS. However, compared to all other Raspberry Pi clone or alternates, this puppy is surprisingly well built from a core level, meaning you install the OS, it's like, I got this. It's not like, oh, the audio is not working or this is not working. It's like core level is surprisingly robust. It does show that, again, the people that work behind it is a bit more serious about it, because they have to make sure this puppy takes off. Without it, it's not gonna do much. Now, it does not have Pi level community. Do not expect that. Again, Pi is amazing, not because of the hardware, but because of the community. It has created a self-sustaining philosophy, so to say. So it's awesome. But this will require a lot of patience from you. Meaning, if you buy this sort of equipment, do not expect, I'm just gonna plug in, I'm gonna plug that and everything is gonna awesome. No, this is for people who are willing to, to get down and dirty. You're gonna do some crunching on this, meaning some kernel compiling on all that jazz. And it does make it great for people who are on high level university students. What does that mean? Think of it this way. Let's say I have many people who are studying instruction set architecture. Okay, ARM holdings does require people who work on this. Intel does require people who work on that. And there are some other also military grade systems that are only used for that hardware. That's an all fine and dandy, but here's the deal. How do you train for that? You don't. That's the reality of it. Right now, you simply don't train for them. You just hope that the instructions that they are teaching you is similar enough where once you go into that, you won't have to start from scratch. Like, I hope this is how it works. However, in this puppy, if let's say India is developing its own processor, which we call Shakti processor, and if Shakti processor is running on instruction set that is similar to this, you can buy this. Again, Shakti processor that may not be mass produced, so it may not be expensive. But if you want to, do your home assignment and start to figure things out, you can use this. That's the whole point. Anybody who's like, polishing themselves how to do kernel and all that, if they are learning in this instruction set architecture, it's gonna have a future. That's the whole point of Risc-V. They do not want to be just a tool. They want to be the tool at the other end of the day. So it's amazing for university level, meaning if you really want to do deep dive and want to understand how instruction set architecture and kernel make love to each other, this is perfect tool for you. Now this is a new beginning kind of system, because I made a first video about Risc-V around 2 years ago. So the Risc-V is growing, but it's growing very slowly but surely. Be mindful, it is absolute at this point in time. Risc-V is here to stay, simply because again, some big boys are putting some big monies into it. For how big? Microsoft kind of big, Meneloc's kind of big, Samsung, Google, Qualcomm. And you're like, why the heck Qualcomm is there? Simply because Qualcomm also has to pay to ARM's holding. They're like, what if we don't have to pay? Like Samsung, like why the heck Samsung is there? Samsung is like, we cannot make our Exynos as amazing as other options. What if we can start from scratch? What if we start from core level, meaning instruction set architecture? They have the fabrication lab, they have the technology to combine the cores that ARMS give them the license to, combine them and make their own custom SoC. What if they even buying the license, throw that part out, use the instruction set architecture from Risc-V and start from scratch, completely from start to finish. Again, Mark 1 product will be garbage, but what would Mark 3 product would look like? What would Mark 4 look like? That would be amazing. So this is the whole point of it. A lot of big people who are pouring serious amount of money into this, and they want to become the Linux of hardware. Linux is real. Linux is here, is running most of the everything that you don't see. For example, servers, you don't see that, but they do work. Routers, you don't see them, but they do work. Android, again, Android you do see, but again, the core is Linux based. So it's here. That's what they want to do, meaning on a hardware level, basic instruction set architecture level, they want to be like, we are the guy. Come to us, we're gonna provide you the tools. Come with us, like, hey, we want to do this, you can do that. It's like they want to be the hardware provider for that. And big players, how big of a player? Intel has joined it. Now you might like, wait a minute, how the heck Intel will create a competing product? They are not. Intel has two divisions into them. First division is the designer division, meaning the people who design the blueprint, so to say, and they are developing the i9, i10, and i10, I don't think they have i10. You get a 1200K and all that. Basically, the people who are developing the hardware, and then you have the people who are manufacturing it, the fabrication lab. Now, fabrication labs have cost issue, meaning they're expensive AF, meaning billions of dollars like chump change to these things. So they want to make sure, like, what if Intel does not sell as well as a next generation because of AMD competition or ARM competition itself, because ARM is slowly starting to creep into server industry. So Intel does have to think about it. It's like, and I'm talking the designing department, they're like, we are competing, we're gonna make amazing product. But the manufacturing, the control C, control V department, they're like, what if we have to place our bets on multiple things? Do not want to put all eggs in one basket. So they are joining in the Risc-V association. Again, this is very early stages on. The idea is you can, like, Samsung can go to them. Again, why would Samsung go? But other companies can go. For example, Google can go to Intel and is like, hey, this is our Risc-V architecture system. Can you, make millions of this design? Intel can do that. So that's why I'm saying, like, it is growing slowly, but it is growing, meaning I do expect a smartphone of this puppy around 5 to 8 years from now. So it could be really good for those sort of things, and for education system is really helpful. And education sector is one of those things. If you can make sure your product sells in education sector, over time it becomes the dominant system. That's exactly what happened to Google Chromebooks basically. So think of it this way. Let's say every university is teaching this instruction set. Why would they teach it? Well, it's real, it's here, it's real, it's being used. So that's much better than to, like, okay, this is imaginary system that we are trying our best to make it as close to x86 as without getting patent sued to us. So that versus this is real, this is here, and you can get job into these companies that are working on it. So once education setup, meaning people who are developing these sort of tools become familiar with this puppy, it can grow exponentially. So I do see some serious potential in this. This is not something that, like, you know, oh, it will die out as a system. Be mindful, Linux did not die out, it became the next big thing. So this has the same potential on a hardware level, and I would love that, like, Samsung would have from start to finish, it's like, this is our processor. I would love Qualcomm is like start to finish our own system, so that you won't have like, oh, if ARM had a bad design, it's like every generation is getting bad design. Why? Everybody bought the course from that. Apple, you know, every other manufacturer, Apple, Samsung, other Foxconn also. So this is a new beginning for system. Again, this is just a single board computer, but if it helps the software side, then we can start to get exponential development. So this was my presentation on Risc-V single board computer. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.